Okay, good. Cool. All right. Thank you for joining me. This is a talk about extending CloudFormation with Lambda Custom Resources. A little bit about myself. My name is DeJonghe. I live in Ann Arbor and work for RightBrain Networks. Got quite a bit of experience around AWS and CloudFormation, as well as some Python. So why would we need to extend CloudFormation? I can think of a few reasons. One reason would be new services. There's sometimes a lag time between when a new service is brought online and when CloudFormation gets around to bringing that to the service. Lookups and computations. Sometimes you need to compile some things or look something up through the API on the fly within your CloudFormation. This is a great way to do so. Also, build patterns, and this is what we're going to be looking at today. Sometimes CloudFormation puts you into a particular build pattern that dictates exactly how your AWS resources are built, and sometimes you would like to build outside that pattern. So that's what we're going to be looking at today as an example. So today we're going to demonstrate how to extend CloudFormation. We'll be looking at the build pattern limitation, reason for extending. So we'll look at some example CloudFormation code for building the Lambda and calling the custom resource, as well as looking at the code itself, and then we'll build and deploy it. So, right, our problem is we need to, the reason that we need to extend CloudFormation is that we've got a limitation. VPC association to a private hosted zone is a limitation for us. You can, through CloudFormation, associate a VPC to a private hosted zone when you create the private hosted zone in CloudFormation. That's the only time. A lot of other resources have a association resource. However, this does not. So if you need to call, or rather add a VPC to an internal hosted zone while keeping things in CloudFormation, what you have to do is you have to take the VPC you've built and send it back to wherever you have your hosted zone. We might build our zone outside of CloudFormation or have multiple VPCs all using the same internal hosted zone, and looping things back around is kind of a pain. So I'll show a diagram on how that might look if we were to do this all in native CloudFormation, and what type of a pain that might be. Let's see. So that's our use case. We want to have a internal hosted zone, either built outside of CloudFormation or built in another stack, and we want to build new VPCs and connect that VPC to that internal hosted zone. So let's say we have an environment that looks like this. We've got this stack at the top that has a bunch of account stuff, might have our zone in it, some IAM, etc. We've got lots of other stacks below it that here at RightBrain we use a nested pattern. So we've got a dev stack that has a VPC, subnet, security groups, and an application, things like that. So how would we get our VPC, this guy here, this address, or this VPC ID, sent back up to the zone to get it added to have that association be built? Well, we'd have to point everything back up at the top, and that would just get kind of hairy. So what we're going to do is, can't quite remember. So this is what we're going to do. We're going to send the zone information to the stack. We're going to build our custom logic, build the Lambda resource through CloudFormation. From there, we'll call the Lambda function through CloudFormation. We'll make the association, and then return back to CloudFormation. So what are the steps in doing so? We got to first set up an internal hosted zone. We got to create a bucket to sync all of our CloudFormation to. We'll set up our CloudFormation, building the Lambda role, building the Lambda resource, building the custom resource. From there, we'll write our code. We'll write a create method, update method, and a delete method. We'll first test locally, and then we'll test in CloudFormation. So set up an internal hosted zone. I've got this kind of as a quick, let's make a tutorial thing going on. So I don't think I can copy that. Nope. All right. So I have an internal hosted zone that I'm going to be using. Let's see. Actually, let's just make one on the fly. What is example.internal? Sounds great. I can't see. Oh, yeah. So somewhere along the line, something's getting cut off, or that's taking forever to... Profile should be default. Where am I? All right, so this sucks because I can't see my cursor. Try that again. So that's weird, right? It's telling us that Route 53 is unavailable. This isn't like a balk of my thing. This is just a problem. So we're going to use this one I've already got set up. How about that? There's our hosted zone ID. And it's called Derek's Lab.internal. Great. Let's go back to here. So let's say that we set up an internal hosted zone using these calls. And I've already got, we just copied the zone ID. We're going to add that as a parameter to our CloudFormation. From there, I've already got a bucket called extend CFN example, so don't try and steal it because I already own it. All right, so I've prepared some files. You guys can check it out after the meetup, or if you're watching at home. This is all set up and ready to go, and it's a good example you can play with and get used to calling the Lambda from inside CloudFormation. So first, we're going to take a look at the Lambda role. Lambdas need a IAM role to be able to run. I'm simply giving it, this isn't the permission part. So interesting thing about Lambdas is that you have to give it the principal of Lambda AWS or Amazon AWS.com. Otherwise, you're not going to be able to call it. Or rather, Lambda can't assume that role. Our policy that I'm giving to this Lambda is that Lambda can run, Lambda can log to S. No, that I don't think I need S3. But anyways, Lambda can log. I can describe VPCs, and I can associate and disassociate from hosted zones. Creating Lambda with CloudFormation is pretty straightforward. A few things that you need to call out are the handler, the role that you're using, where to find the code. You can put it inline or you can point to S3. and then the timeout runtime. There's quite a few other properties, but these are the ones necessary for this example. Our custom resource for this example, pretty straightforward. The type is custom, and then you can make up any name you like. And that's pretty much just adheres to the namespacing that CloudFormation does. From there, you've got properties. One of those properties is absolutely necessary. That is the service token. That service token, in this example, we use a condition to say if Lambda is available, so that our CloudFormation is able to boot in regions that don't have Lambda. It'll just ignore all of this. And then it just grabs the ARN of the Lambda function. So service token, pass it the ARN of the Lambda function. And then all of the other properties are going to be inputs to our Lambda function. We'll get to that shortly. In this example, we are passing region, hosted zone ID, and the VPC that we want to associate. The Lambda handler. This is the code that actually gets ran when Lambda is invoked. Lambda itself has 2 arguments that you need to allow to be passed to it, event and context. Event is information about what's going on, why it's being invoked, and then the context is kind of like a runtime environment, special object from AWS. So in this handler, what we're doing is we're initiating an object. That object is called zone attach. We're calling our variable attachment, and then looking to see what type of event we have. CloudFormation has a special event. I think I've got an example of it here coming up. But one of the properties of that, or attributes of that event, is request type. And that's going to be delete, create, or update. Those are the 3 different request types that CloudFormation will pass to you through the custom resource. Each one of those, I've got a method on this class that adheres to that, either the delete, create, or the update. And if we do not find a request type that we know about, we log and fail. We'll talk a little bit more about this send thing down here in a little bit. So let's talk about the event. The CloudFormation passes a few things that we want to talk about through the event. When you use a custom resource in CloudFormation, your event's going to have a request type, which is either going to be a create, update, or delete. It's going to have a response URL, which is the S3 location that you are required to post back a response to. It's going to have the stack ID of the stack that is actually calling the custom resource. It's going to have a resource type. That's that custom : whatever you decided to name it value. It'll also have the logical resource ID that you named your custom resource. It'll have the physical resource ID, and this is only if you are updating or deleting the resource. And we'll talk a little bit more about that in a moment. Resource properties, this is all of the input, right? These are the properties that were under the service token. This is going to be, in this example, our region, our hosted zone ID, and our, what was the last one? VPC ID. Okay, and then old resource properties. These are, if you're doing an update, these are the old resource properties so that you can do a delta against your resource properties versus your old resource properties and find out what's changed. So you can determine if you can do an update, if you need to do a full replacement, things to that effect. So this is an example of an event. You can see here we have our stack ID, which is this big ARN. Here are our resource properties. So this is everything that came from CloudFormation. This is our hosted zone ID. This is exactly how I typed it into CloudFormation. So this is a one-to-one mapping there. So hosted zone ID, region, VPC ID. These values were passed in from CloudFormation. We'll go back to that right here. our service token, which is just the ARN of the Lambda function itself. We have some more things like the response URL. Again, like I said, that's a S3 location that is a signed S3 location, so you can post a response back. The request ID, resource type, request type, service token again, okay, and the logical resource ID. So for creates, we're going to just go ahead and create the attachment, right? So we're going to update the hosted zone with the VPC. In Bodo, that we're able to make this call. However, in CloudFormation, we're not. That's why we're extending CloudFormation to do this. Simply just pass it a few things about ourselves, the hosted zone ID, the VPC region, and the VPC ID. Log any responses, and throw exceptions if we fail. Oh, wait. So, okay, so there's a couple tricks in here I want to stop and talk about, right? This updating false. So in this scenario, if any of my properties have changed, that means we're going to get a update to our custom resource, right? So if you change a property in CloudFormation, that triggers an update. That's the only time an update will happen. In this example, if any of those things updates, that's going to require replacement. So in this example, an update, let's go and look at updates real quick. An update, we're going to create a new, just create and then delete the old one, because all of them require replacement. This is the same pattern you'll see with things that require replacement. You first create and then delete. And then send status. You see the self-send status. We'll get to that very shortly. That's very important. Yes, here we are. So the CFN response, this is actually a library written by a guy named George. I've got it on the blog and links to all his stuff. Really, really awesome little library that allows us to post back to CloudFormation very easily. It takes a few arguments, and those arguments are the event. It's looking for the event to use the request URL, stack ID, request ID, physical resource ID, all those things to kind of formulate the response back to that S3 URL so that you don't have to write that post. Uses the context for the log stream name. The response status is either a success or a failed. He's got these hard-coded into variables that you can use, and we'll see that in a little bit. This tells CloudFormation if you have successfully updated or created or deleted, or if you failed and the stack needs to roll back.
So if you didn't return this, would just be in a constant state of applying, or?
It would, if you did not put this in there, the send status function wouldn't run. It would error out, and then you'd sit there and wait for timeout, it's not fun. And when we talk a little bit about testing, that's why I suggest testing locally, because if you do test in CloudFormation and you don't set the timeout, you're going to be sitting there waiting for some stuff if you don't have everything 100% correct. I also recommend that you first set up your response before you start writing code, so that if you are testing CloudFormation, that you know that your response is going to be good, and that you don't sit there and waste 3 hours of time waiting for it to time out. The request was the question was, if we don't send a success or a failure, what happens? Does it just time out? Response data. So this is actually really cool. This is a dictionary object that you can address from within CloudFormation with the get@, intrinsic function. And then, of course, the physical resource ID. This is a string that is returned within CloudFormation when you ref the custom resource by the logical ID. So this is what I set up a method usually in my classes that just sends status. At any given time, my class will have the event, the context. Pass or fail is obviously an argument we pass into it, and then reason. So reason's really cool. This is, I think I actually missed it in the last slide. Response status. Yeah, I missed it in this slide. Apologize for that. So reason is what shows up under status reason when things fail in CloudFormation. So if you get, say, creation of this fails, you want to know why. This is a really great place to go ahead and just throw your error message. Your full stack trace might be a little bit big, and you should probably just put that in log. But an error message is really great to tell people why it's failing. And then, of course, your response data and anything else. We already looked at the updates. So again, that trick of saying update true, what that does is makes it so that once we get through the create, that we don't send the status to CloudFormation saying, hey, we're done, everything's cool. We got to wait and wait for the delete and then send a success message. Deletes. If you're updating, you're going to have to look for the old resource property. So that's what's going on here. If updating's true, then we go ahead and look for all the old things and delete the old resource rather than the current resource, right? So this is the continued. So here what we're doing is we're setting the hosted zone, VPC, and region either to be the current or the old ones. And then we're going to go ahead and just disassociate this VPC from the hosted zone. Again, if we're updating, if we're not updating, go ahead and send success. If we are, we don't want to send anything. We'll wait for updating method to send that success message. You can see here, if we have any exceptions, just print a message about, why it failed. And then obviously log anything that you can and send your status as failed. So testing locally. This is kind of weird, right? This is something everybody needs to wrap their minds around because testing in Lambda is really hard and it takes a lot of time and it's not very fun at all. So what I do is I actually set up a main function inside of my Lambdas so that I can run it locally. And then part of the Python standard library is the argparse ops parse. So I use those to create an event in this main function and call the Lambda handler with no context. Context set is none. And then within that, within my function, sometimes you'll see things like if I'm using Bodo, I'll say if context is none, use a profile. If context is none, just go with whatever the role has. So with this one in particular, we can pass a couple flags, and that'll give us the desired. It'll go ahead and let us test there, and we can also use a profile rather than having to rely on using a default. Let's take a look at an example of that real quick. All right. A little too far. There we go. All right, so here's our if main. Just add a bunch of options. For each of these, if you do want to test updates, you need to add in all the old stuff just to be able to mimic that event and give it the old resource properties. So obviously all of these things are required, except for the old stuff. And if we're not updating, then just go ahead and send your resource properties as we have in CloudFormation. However, if we are doing an update, then we'll go ahead and also send the old resource properties. We'll call our Lambda handler with the event and none. All right. Testing in CloudFormation. We already kind of went through this, but it's super painful if you don't have things 100% correct. So I definitely encourage you guys to test locally and make sure that things are looking okay before you send it all out to CloudFormation. Or if you do test in CloudFormation, set the timeout just because it's it's going to bite you. It really hurts sitting there waiting for that, and then you just run another create, and you change the stack name a little bit, and now you've got 30 stacks that are all failing and timing out, and it's really just not very fun. So if you do get yourself into a rough spot, there is something in this this GitHub repo that'll help you out. It's just a return true Lambda that you can upload to your function. So say you finally got your creates and your updates working, but your delete's not working. You're trying to tear down your stack, but now you're timing out and you can't tear down your stack. You can't tear down your stack. Luckily, CloudFormation just had an update where you can retain resources if things fail when you're doing deletes and so on and so forth. However, if you want to really get through, there is you can just upload something to the Lambda. You can upload new code to the Lambda that just does a sends return true, and then you can delete that way. So cool. Go through. Actually, let's boot this thing. Hosted zones. Yeah. I got a bucket. We synced. I got to go back to my original profile so I can see my cursor. Oh, come on. Cool. So that's on its way up. It might take a little bit. You can see here we have this hosted zone associated to, it's associated to something, I swear. There it is. It's associated to 2 VPCs right now. We should see a new VPC pop up there shortly. It'll be called Extend CloudFormation something or other. Yeah, so here we go. This is a nested stack pattern. This is a top stack that calls a bunch of other templates. We can look at it in here. So the top stack takes just these 3 parameters, trying to keep it simple. We've got a condition for if not in any of these regions, Lambda is not available. And if we're in US standard, which is just blows my mind that they did this, but if you're in US East 1, your template URLs have to be s3.cloud or s3.amazon aws.com. However, if you're not in US East 1, then you have to concatenate S3 dash the region name. They really should do S3 dash US East 1. Really make everything a lot easier. But other than that, we've got these really long paths to our templates. Custom logic. This is where this is a stack where our that's the stack where our Lambda function's built. We'll look at that in a second here. Exactly how we saw it in the slideshow. Let's see. IAM, that's the Lambda role that we took a look at earlier. We built the VPC. This is pretty much a blank template, just builds a VPC. And then we attach the hosted zone with the custom resource. We're pulling the region from the pseudo parameters. We're roughing the internal hosted zone, which is passed through our parameter to this top stack, and we're getting the VPC ID from get at of the outputs out of the VPC stack here. Let's see how we're going here. Oh, create complete. Great. And let's update. It's not labeled. Anyways, there's a new VPC there. Wouldn't be able to do that with CloudFormation because I built this internal hosted zone manually, which is a huge no-no, of course, right? But I did. So, all right. Any questions? Concerns?
Do you have any other scenarios besides association?
Oh yeah, absolutely. So literally just before everybody walked in, I've been using Docker a lot, and there's this one app that uses environment variables, but that environment variable is a huge JSON string. And I didn't want to join the database URL, the Redis URL, and all this stuff together inside CloudFormation because I'd have to do a join, escape all the JSON because we're inside JSON. You can't, writing JSON inside JSON is a real pain. So I just pumped it all into Lambda and spit out a single string. What about, okay, get this one. You've got, you don't want to do subnetting, right? And you're building VPCs all the time. Let it do it for you. We've done a project where we look up all the VPCs. We say, okay, these are all of our citers. Pick a citer that's not in this, and then do subnetting for it. So I've got a citer. I found a citer range that's not in use. Give it a parameter. Say, okay, I don't care what my citer range is, but I want it to be a /22. It goes, it finds one, and then it says, okay, well, this region has 3 availability zones. The best I can do is give you 8 subnets, and then subnet them out and return all of that so that you never have to do subnetting again, because although we all know it by heart, it's not that fun, right? NAT gateways lagged behind CloudFormation for about a month, if not more. I needed them right away, so I went ahead and built the template for that. S3 gateways lagged behind. That was about the same time period. Built one for those.
Yeah. So do you ever go back and modify that template when they add the resource?
Yeah, absolutely.
Abandon your custom resource?
Oh yeah. I mean, because I'm not as good as they are. But the lookup stuff's definitely valid. If CloudFormation puts you in patterns that you don't want to use, these are really the 3 main reasons I've found to extend CloudFormation. Do you guys have any other?
Could you use it for user data? Like if I have a 500 line user data stream, that makes sense instead of me having to like escape every single line. I could have just I could base 64 and go with the bash script in S3 and then return it or something like that, maybe.
Right.
We deal with that stuff by generating CloudFormation. Like we don't directly type the JSON. Like very quickly go to either Python or Go to generate it. Some of that we don't have that problem with.
We do the opposite. We write our CloudFormation scripts, but we write them so generic that we can use them all over the place. And then for user data, we typically just say, okay, our user data will say, make sure AWS CLI is installed, updated, and then pull this script from S3 and run that.
So 10 ways to skin the cat, I guess, really.
Yeah, of course. User data is one of those problems that everybody has their own way to solve, but yeah, I don't know of anything else. I mean, those 3 are really the use cases that I've found. If anybody else has any use cases, I'd love to hear it.
Could you like auto tag maybe or something? Like could you? I guess config kind of solve that, doesn't it? Maybe not.
Auto tag.
Like
So have you seen the CloudFormation? Have you tagged a CloudFormation stack? It's really cool. It tags everything in it, and then if it has child stacks, it tags everything in the child stack, and so on and so forth. So if you tag CloudFormation stack, everything within it gets those tags.
So VPC is one. I hope you didn't say this and I was zoned out. Another one that we use is to look up AMIs.
Mm-hmm.
I guess that's an example, but that's
Yeah.
a useful thing.
They've actually got 2 examples.
Yeah, that's one of the ones that they
Yep.
of highlight for.
I will preach against their other example. Let me find it real quick. Custom resource examples. Yeah, so they've got 2 examples here. Let's see. Buried deep in their docs. One of them is looking up AMIs, and then the other one is looking up stacks, other outputs from other stacks, right? I don't particularly like that one, and try and voice my opinion against not using that because there's no. Well, they do have a way. There's a trick to get it to update, but if they call it the network stack lookup or something like that. And it's a pattern we typically use. Is we'll build a network and then build with a nested pattern and keep that as a standalone stack, and then we'll build different stacks on top of it. Kind of like that pretty little diagram we had. So say this guy's your network stack, say this guy's your network stack, and these are a bunch of app stacks that boot off of it. There's a node example that will go look up outputs from this. And the reason I don't really care for it is because there's no way for it to go and relook those up if you do an update. So that's why I like to pass them in as parameters. We have some functionality that does that. So we look them up every time we do an update just to make sure that they're 100% sure. The only other way I see, you could modify that node example they have and add a version number. Then you have to track your version numbers all the way through, so on and so forth. And it's fun. But yeah, they have examples out there. They're great examples. I like looking up AMIs. That's fun. But that's again a lookup or computation.
Do you do by tag, or what do you look up about the AMI versus instead of using a map?
Yeah, it's.
Is it based upon like app type or something? I mean,
I think they actually scrape the page or something like that. Place custom resource. Let's find it. Oh, it's Node. Who knows how to read that? Let's see. So the regexing.
The latest. Okay. So basically, so you don't update your template with static AMI IDs, probably.
Right. Which is awesome. You know, if you guys build your own AMIs, that's going to be way easier to look up than what we got going on here, because you're going to know what you've got it tagged as. You're in that account already. You can see them and stuff like that. Use Bodo or something to that effect.
So EC2 described instances or described images is what?
Yeah.
Is the core source of data.
Good sort. There it is. Their examples are all in Node, so now you have one in Python. Let's go give the guy credit who has done an amazing job here. CFN response. George, there he is. So George here has written this Python script. It just posts the body back to the S3 URL, but it's really simple, easy to use. Inside of our example, You'll see we got a requirements file and CFN responses in there. There is a, let's see, build Lambda script in here. Just hops into that directory. Pip installs to that directory and then zips it up. And that way we get George's CFN response and we're able to use it. This is actually, yeah, he's got this in PyPy somewhere. There it is. There it is. So, yeah, I really like this library. It was a long couple days before I found this, waiting for things to roll back and so on and so forth. Cool. Any other questions, ideas? Gonna run home and use it to build API gateway, right? Actually, that's another one, right? So the Swagger upload to API gateway, you can't do that through CloudFormation. But if you were to, like, say, point at a Swagger file in S3 and then make that call through Lambda rather than actually putting all of your API gateway definition into CloudFormation, why not just notate your code while you're building it, and then you've got a nice Swagger doc at the end. That way you can build the API gateway directly off of that. That's a pretty cool pattern somebody here in the office did. So props to Tanya. All right. Cool. That's all I've got.